Have you ever pondered the possibility of all the continents once being a single unified landmass? A question that may initially seem far-fetched, but in the world of geology, it's a concept that's been explored quite thoroughly. Welcome to the fascinating tale of Pangea, a term derived from the ancient Greek for all lands. This isn't a mere work of fiction, but a scientific hypothesis that was first proposed by a German meteorologist named Alfred Wegener in the year 1912. Wegener wasn't just a dreamer, he was a scientist, a keen observer of the world around him. His curiosity was piqued by the jigsaw-like fit of the eastern coast of South America and the western coast of Africa. But it wasn't just this curious alignment that sparked Wegener's theory. He delved deeper, scouring the globe for more evidence. What he found was a series of fossil records that seemed to defy the boundaries of continents. The fossils of the same prehistoric plant, Glossopteris, were found across India, Australia, and Antarctica. Similarly, fossils of a reptile, Mesosaurus, were discovered in both South Africa and Brazil. These findings were peculiar because these ancient organisms wouldn't have been capable of crossing the oceans or surviving in vastly different climates. So how did they end up in such distant lands? Wegener proposed that they didn't travel across the seas at all. Instead, they lived on a single supercontinent that later split apart, drifting to form the continents we recognize today. This was the birth of the continental drift theory, a radical idea at the time, which suggested that our Earth's landmasses aren't fixed in place but are instead slowly moving. Despite initial skepticism from the scientific community, Wegener's hypothesis, underpinned by his evidence, has shaped our understanding of Earth's geological history. It's testament to the power of observation, curiosity, and a willingness to challenge established beliefs. So, we see the birth of an idea, the concept of Pangea, conceived in the mind of Alfred Wegener. Now let's dive into the depths of time, about 300 million years ago when Pangea started to form. Imagine our planet not as we know it today, but as it was during the late Paleozoic and early Mesozoic eras. The Earth's crust, much like today, was divided into several large and small tectonic plates. These plates weren't static, but rather floated on the semi-fluid mantle below. Much like pieces of a vast jigsaw puzzle, these tectonic plates shifted, collided, and drifted over millions of years. The constant movement of these plates, driven by the Earth's internal heat and gravitational forces, led to a fascinating geological phenomenon. Now picture this. Over the course of millions of years, these plates gradually moved towards each other. They collided, crunched, and folded, raising mountains where there were once seas. This grand tectonic ballet led to the formation of a supercontinent, a landmass that spanned from the north to the South Pole. This supercontinent, as we know it, was Pangea. As the tectonic plates moved towards each other, the Panthalassa Ocean that surrounded the supercontinent began to shrink. The land masses that were once scattered across the globe were now coming together, forming a singular massive continent. The result was a landmass so large that it made up nearly 1/3 of the Earth's surface. This process was not a swift one. It took about 100 million years for Pangea to fully form. Just to put that into perspective, that's over 20,000 times longer than the entire span of human civilization. The formation of Pangea was a transformative event in Earth's history. It changed the course of life on this planet, influencing climate, sea levels, and the evolution of species. And thus, through the dance of the tectonic plates, Pangea was formed. This geological marvel, a testament to the dynamic nature of our planet, stood as a singular landmass for nearly 100 million years before it began to break apart, setting the stage for the world as we know it today. Imagine the world as one continent, one vast landmass. What was life like on Pangea? Picture this, an immense supercontinent stretching from pole to pole, its climate and environment unlike anything we experience today. Pangea was a world of extremes, a place where the interior was arid and dry, while the coastal regions were lush and humid. The climate of Pangea was largely dictated by its sheer size. The colossal landmass was so extensive that the interior was miles away from any coastline, resulting in a desert-like condition. Yet, in direct contrast, the coastal regions were subjected to constant rainfall, creating a fertile, verdant environment. Now, let's delve into the flourishing life during this era. Amidst the arid heartland and lush coastlines, large inland seas and swamps were scattered. These bodies of water were teeming with life, providing ideal conditions for a multitude of species to thrive and evolve. It was in these fertile cradles of biodiversity that life began to take on new fascinating forms. One of the most intriguing aspects of Pangea's life story is the evolution of species during this time. This was the era when life on Earth truly began to diversify. In the lush, swampy areas, plant life exploded, providing a rich food source for a myriad of creatures. The arid interior became home to hardy, adaptable species that could withstand the harsh conditions. However, the crowning glory of Pangea's biodiversity was, without a doubt, the rise of the dinosaurs. These magnificent creatures, which have captured our imaginations for centuries, first appeared during the late Triassic period, around 230 million years ago. They evolved and diversified rapidly, eventually dominating the landscape and ruling over Pangea for over 100 million years. Life thrived, evolved, and diversified on this supercontinent, setting the stage for the world as we know it. This was the stage upon which the drama of life on Earth played out, a stage set by the unique conditions of Pangea. It's a testament to the power of evolution and the enduring resilience of life. But as they say, nothing lasts forever, not even Pangea. Let's fast forward to around 200 million years ago, a time when the seemingly unshakable unity of Pangea began to falter. The supercontinent, as solid and as steadfast as it seemed, was not immune to the relentless forces of nature. The same tectonic forces that played a pivotal role in its creation were now the harbingers of its dissolution. Imagine the surface of the Earth as a massive jigsaw puzzle. The pieces of this puzzle, the tectonic plates, are in a constant state of motion. They drift, collide, and pull apart, changing the face of our planet in a slow but ceaseless dance. It was this dance, this pulling apart of the tectonic plates, that set the stage for the breakup of Pangea. This fragmentation didn't happen overnight. No, it was a gradual process unfolding over millions of years. As the tectonic plates beneath Pangea started to move apart, the supercontinent began to crack and split. This vast landmass, once a symbol of unity, was slowly torn asunder, giving birth to the continents we are familiar with today. Let's bring the Atlantic Ocean into focus as an example. Picture a massive body of water, stretching from the icy realms of the Arctic to the warm currents of the southern hemisphere. But this vast ocean didn't always exist. In fact, it was born from the breakup of Pangea. As the tectonic plates moved apart, a rift was created. This rift gradually widened, filling up with water over time. The result? The birth of the Atlantic Ocean, a testament to the power of tectonic forces. The breakup of Pangea was not an end, but rather a beginning, a new chapter in Earth's geological history. It was a transformative process, one that sculpted the face of our planet and laid the groundwork for the world we inhabit today. And so, the world as we know it began to take shape. Pangea, a world from a bygone era, but its legacy lives on. Let's journey through the corridors of time to better understand how this ancient supercontinent has shaped our world today. The breakup of Pangea, a colossal event in Earth's history, has left indelible marks on the face of our planet. Let's consider first the distribution of species. When Pangea was whole, a dinosaur could have sauntered from what we now call South America to Africa without getting its feet wet. But when this monolithic landmass began to break apart, it created barriers, transforming the evolutionary path of life on Earth. The continents drifted, carrying their unique cargo of life, and new species evolved in isolation, shaping the rich biodiversity we see today. Next, let's turn our attention to the formation of climate zones. When Pangea existed, it was one massive landmass surrounded by an enormous ocean, creating extreme and harsh climatic conditions. But as the continents drifted apart, the distribution of land and sea changed dramatically, giving rise to the diverse climate zones we experience today. The legacy of Pangea is also etched into the landscapes that surround us. The jagged peaks of the Himalayas, the vast expanse of the Atlantic Ocean, the lush Amazon rainforest, all are a direct result of the tectonic forces unleashed during the breakup of Pangea. And finally, the study of Pangea has propelled our understanding of plate tectonics and Earth's geological history. By piecing together the jigsaw puzzle of continental drift, we have uncovered the mechanisms that have shaped our planet over billions of years, allowing us to peer into Earth's past and perhaps to predict its future. And there you have it, The story of Pangea, a testament to the dynamic and ever-changing nature of our planet.